Welcome, ladies and gentlemen, to the practical today, which is on acceleration and using the ticket timer to actually calculate the acceleration of a trolley. In this particular case, what we are doing is we're going to run a wooden trolley down the ramp here, and the ramp will represent acceleration, because it will obviously go from not moving to having accelerated by the end of the inclined plane. As usual, the prac write-up will come on, so can you please get that down, and when you are ready you can restart the video. Okay, now that you're ready to go, what you can see we have here is we have a wooden trolley which will run down this particular ramp. We have a ticket timer here, and that's obviously connected to the power box. And again, it's very important with this particular activity that you work from the fact that it is at rest and it will be moving, because the basis of this practice is to try and define what acceleration is and to try and discover why we would measure acceleration in meters per second per second. We measure speed in meters per second, but acceleration is always measured in meters per second per second. So let's run the trolley. So obviously what I'll do there is I will take that off. I will make sure we set that up, turn on the ticket timer, and let it be on for a short time. And there we have it. And what you can see from here is, as per normal, we have a tape that's produced, and even though it's a little bit hard to see, it has actually produced a set of dots onto the screen. Now let's take a closer look at the actual tape itself. You can see here at the start that you have all of the dots fairly close together. Remember, each one of those dot spacings equals 1/50th of a second. Now as we move our way down, you can hopefully work out that what's happening is the space between those dots is getting larger and larger and larger. So what that would mean is that for the same amount of time there's more distance being covered by the trolley, and this helps to understand what acceleration is. What I would like you now to do, please, is if you go to the content section of this particular of Connect, you'll find a copy of a drag strip that looks like this. Once you do that, you can come back to the video and I'll explain what you'll need to do with it. Okay, now that you've downloaded and printed off your piece of drag strip, the first thing that you need to do is you need to put a line through the first dot, because that's going to be where we're going to be starting to look at how the acceleration has occurred. You then need to count an even number of dot spacings, and I always use a nice even number of 10. You need to count the dot spacings, not the dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then put a line through the next dot. That then needs to be labelled as number 1. Then again you count the same number of dot spacings, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and put a line through there. So again, once again do the same, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and put a line through there and put the number 3, because that's the third. Again, do the same, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you can probably stop it there. Then what you will need to do is you need to get a pair of scissors and cut each particular section. So now all you've got is just the length of ticker tape. So again, we cut, and cut. Then what you need to do is arrange these in order, so from 1 to 4, and stick them into the prac writer, which looks at the graph. Because as you can see there, what's happening, and it's probably better if I do it this way, what's happening is, you see that for each same length of time, because each of those is 0.2 of a second, each of those has increased in the distance that the car has travelled. So in this case we've got what's called positive acceleration, and positive acceleration is basically getting faster. But the interesting point about when we define acceleration is in that these tapes measure the speed, because we can calculate the distance over the time, and that's why speed is measured in meters per second. The thing that we need you guys to work out is acceleration. How do we define acceleration, and then why do we use meters per second per second? So it's that second time coefficient that becomes the crucial one here in acceleration. Once again, if you have any dramas, please see your science teacher and get any issues that are sorted out. Thank you very much.